Hello guys, welcome to another video again in my channel. So in today's video we will be looking at sequence and series. So this is ordinary level mathematics. Okay guys, so if you are new to my channel, please don't forget to subscribe, like the video, and don't forget to share to your friends. Okay guys, there is nothing much here, so let me just go directly to the point. Alright, so we'll be looking at series. So let's look at what is series all about. Okay, so let's look at the definition. A series is a set of terms in a defined order with a role of obtaining the terms. Example of sequences includes um sorry, a sequence is a set of terms in a defined order with a role of obtaining the terms. Example of sequences include we have 1, 3, 5, 7, 9, and it continues, or 1, 2, 4, 8, it continues. Okay, so note that in the above sequence, each term is two more than the preceding term in the first case, and in the second case each term is twice the preceding term. Like saying, okay, let's say we are here, right? This is the first case. Okay, we have 3. So if you add 2, we have 1, if we add 2 we have 3, if we add 2 we have 5, if we add 2 we have 7, and if we add 2 we have 9. But let's look at the second case. So this is 1. 1 times 2 is actually 2. 2 times 2 is 4. 4 times 2 is 8. Okay, that is what this point is saying. That in the above sequence, each term is 2 more than the preceding term in the first case, and in the second case, each term is twice the preceding term. Okay, all right. So in sequences, we have finite and infinite sequences. So that can actually come to your paper 1. Okay, that they might ask you that which of the sequence is finite or infinite. All right. So a sequence is considered finite if there exists a last term. It means that if I have terms in a sequence, right? Like let me say I have 1, 3, 9, 7, 27. Let me say right up to 64. Since 64 is a last term, it means that that sequence is actually a finite sequence. Otherwise, a sequence is infinite. Okay, if there is no last term, that is, for example, we have the two sequences above are infinite, as we have seen. This is it. So we have 1, 3, 5, 7, 9, right up to a value that we don't know. So these two sequences are actually infinite sequences. This point here is very relevant when you are answering your paper 1, okay, for the ordinary level mathematics. All right, let's look at series. Okay, so a series is a form. A series is formed when the terms in a sequence are added. So this is actually a sequence. So if you add the terms here, like saying 1 plus 3 plus 9 plus 27, right up to plus 64, actually that is a series. Okay, but when the terms are separated with commas, it is actually a sequence. But here we are talking about a series. So this is actually a sequence, and if you add the terms, we have a series. All right, so that is it. Now, in sequences and series, we have two important topics. We have the arithmetic progression, AP. So what is actually an arithmetic progression? So an AP is a progression. Um, an arithmetic progression is a progression in which the difference between any two consecutive terms is in a series. Sorry, an AP is a progression in which the difference between any two consecutive terms in a series, it was supposed to be in a series, is a constant. Okay, that is a typo error. That is, it was supposed to read an AP is a, here was supposed to be is. An AP is a progression in which the difference between any two consecutive terms in a series is a constant. So that's actually typo error. Now that is, we have 0 plus 2 plus 4 plus 6 plus 8, and we have to observe that if I take 2 minus 0, I'll have 2, and if I that is 2 minus 0, I have 2, and if I take 4 minus 2, I will definitely have 2. Equally, if I take 6 minus 4, I will still have 2. Therefore, there exists a common difference. Okay. All right. So that is for an AP. So an AP is a progression that there exists a common difference in a series, in the series given. Okay. All right. So let's move to the next point. Okay, next subtopic. So let's look at finding the terms of an AP. So how are we going to find the terms of an AP? We have to consider an AP whose first term is A and the common difference is D. Then the first three terms can be obtained as follows. Okay, so the first term is T1, which is equal to A. Okay, and how do we obtain A? It means we already know that for an AP, right? The n term is given by A plus um n minus 1 times d. Okay, so n is actually the n term, the number of terms. Okay, so for the first term we have a, since 1 minus 0 is 1, and sorry, yeah, there's a mistake here. It was supposed to be, let me correct it. Here was supposed to be 1 minus 1, not 1 minus 0. Supposed to be 1 minus 1 here, like this. Okay, so that we have a plus 1 minus 1, which is 0, and 0 times d is 0. So 0 plus a is actually a. So for in an AP, the first term, the first term t1 is a, and the second term t2 is a plus d. How? Because we have a plus 2 minus 1, where 2 is our n. Okay, according to the general term, as we are going to see. And then again, the third term is a plus 2d. Okay, how? Because yeah, there is a mistake here. Actually, there was supposed to be 4 there, 3 here for the third term. Yeah, for the third term we have a plus, a plus 3 minus 1, which is 2. Okay, so that is it. All right, so hence in general, an AP with n terms has with n terms has end or general term as Tn equals to a plus n minus 1 times d. Okay, so that is the general term or the n term of an AP. All right, so let's continue. Now, with that, let's look at some of the examples. Okay, so example 1 reads, the first term of an AP is 3 and the common difference is 4. Find the third and the 50th term. Okay, so here our first term, which is a, is 3, and our common difference, which is d, it is 4. Okay, so the general term that we know is Tn equals to a plus n minus 1 times d. Okay, hence if I'm looking for the third term, what is my third term according to this formula, according to this procedure up here? My third term is T3, which is a plus 2d. Okay, so it means my T3 is actually a plus 2d. With that, I can just substitute my a and I substitute my d for me to have the third term. So I have T3 equals to 3 plus 2 times 4, and 2 times 4 is actually 8, plus 3 is actually 11. Hence my T3 is equal to 11. All right, so that is it for my T3. So please, this is for ordinary level students. I hope the video is well simplified. All right, so what next? Now, that is our third term. So let's look at the 50th term. Okay, for the 50th term, implies T50 equals to a plus 49d according to this procedure up here, since the term are dropping. So you actually drop this this part containing d by 1. Okay, so that is it. So since T50 equals to a plus 49d, implies that if I substitute my first term and my common difference, I will have that my T50 equals to 3 plus 49 times 4. Okay, and equally my T50 will just be equals to 199. So that is my answer. Okay, so let's look at the second case. The second term of an AP is -5. that is the second term of an AP is -5 and the ninth term is -11. Find the first term and the common difference. All right, so let's look at the solution. So they said the second term, so it means my T2 is -5, which, well, I know that my T2 from here, T2 is A plus D, hence my T2, which is A plus D, is equal to -5, and I can call that equation 1 again. And the ninth term is -11, it means my T9, which is A plus AD, will be equal to -11, and I can call that equation 2. Okay, hence I can solve equation 1 and equation 2 by subtracting, like I'm solving them simultaneously. So I have 1 minus 2, this is my equation 1 minus equation 2. Okay, so I will take my A minus A is 0, then my D minus AD is actually -7D, then my -5 minus 11 is 6. Okay, hence my D is equal to -0.86, and that is my common difference. Okay, then the question asks for the first term and the common difference. So this is my common difference. Okay, now means from any of the equation I can substitute D for me to have A. Hence, from equation 1, my equation 1 says A plus D equals -5. So this is A plus D equals -5. Okay, now if I substitute my D, which is -0.86, I will actually have my A. So this is my D here, and then for me to have my A, I have to take this term and cross it the other side. Hence, my A is just equals to -4.14, and that is my first term. So it means in the AP that was given, that the second term of an AP, that means the AP, the first term is actually -4.14. Okay, and then the second term now is -5. So actually you can obtain all the terms using this procedure here. Okay, all right, so hence, as the equation asks, my first term is -4.14 and my common difference is -0.86. So that is it. All right, let's move to the next question. Okay, question 3 reads, given that the first term of an AP is thrice the seventh term. So these are the questions that actually confusing students. So let's look at how I can handle this case. Okay, given that the fifth term of an AP is thrice the seventh term, find the common difference. Given that the first term is 6, hence find the 15th term. All right, so let's look at the solution. That given that the fifth term of an AP is thrice the seventh term, it means that T5 is equal to 3 times T7. Okay, so my sorry, so it means here was supposed to be 15, not fifth. That is a type of error. Given that the 15th term, it was supposed to be given as the 15th term of an AP, not fifth term. So it means that T15 is equal to 3 times T7. Okay, according to what the question is saying here up here. Hope it is well understood. Given that the 15th term of an AP is thrice the 7th term, okay, means T15 is 3 times T7. Okay, but what is T15? T15 is actually A plus 14D, and equally T7 is A plus 6D. Okay, and then we can substitute them here. So it means that we have A plus 14D, which is our T15, it being equal to 3 times T7, which is A plus 6D. Okay, and from here, right, we can actually expand this bracket. So I have A plus 14D equals to 3 times A is 3A, 3 times 6 is 18D. Okay, so that is it. From here, right, we can collect like terms. Like I take this 3 and I send it this way, and I take this 14 and send it on the other side. Okay, so at the end of the day, I have A minus 3A equal to 18D minus 14D. And A minus 3 is actually -2, and this of 18 minus 14 is actually 4 with a D there. All right, so but A equals to 6 implies that if I substitute my A, which is our first term, and the first term is 6, so I'll put my first term there so that I can actually obtain my D. If I -2 times 6 is actually -12, hence I will divide all through by 4 to make D alone. Hence my D is just equal to -3, so that is my common difference. So given that the first term, as I said, find the common difference. Given that the first term is 6, and hence the 15th term. So For the 15th term, we have that, we have a plus 14d, as we all know. Okay, hence t15 is equal to a plus 14d, which implies t15 is a, which is our 6, and our 14. Then what is our d, which is the one we just obtained, which is the common difference, so it's negative 3. Hence our 15th term is just equal to 36. All right, hope it is clear. Sequence and series seems somehow difficult to some students, but it's very easy once you know that if they're talking of 7 term, it means a plus 6d, 100 term, it means a plus 99d. Okay, and with this logic here, that something is thrice the order or 4 times the order, please be careful with it. This is the exact procedure you have to follow. All right, so let's look at the sum of an AP denoted as Sn. Okay, so if T1, sorry, that's supposed to be 1 here. If T1, T2, T3, if T1 plus T2 plus T3 plus T4 plus right up to Tn minus 1 plus Tn as sum of the first n term of an AP whose last term is L, then I have Sn equals, which is the sum of an AP, Sn equals to T1 plus T2 plus T3 plus T4 plus Tn minus 1 plus Tn. Okay, so that is it. It means the term here is actually means from this term, this is the previous term, then before the last term, which is Tn. Okay, all right. From there, right, what is our, we know that our general term, which is Tn, is a plus n minus 1d, right? So it means here I'll put but for the first term, as we all know from the previous slide, T1 was a. Okay, and then our T2 was a plus d, our T3 was a plus 2d, T4, right, this is it here. Okay, so we have a plus a plus d plus a plus 2d plus a plus 3d, right up to L minus d, then plus L. This L minus d came from this part here. Okay, this L minus d here, because L is actually the last term. Okay, so L is the last term. So for us to get the previous term before the last term, means we have to take L minus the common difference. So we actually have the previous term before the last term. All right, so what next? From here, right, by reversing the term above, it means we are actually deriving the sum of an AP. Okay, the formula that we all know. Okay, now by reversing the term above, we have that Sn equals to L plus L minus d plus L minus 2d plus L minus 3d, right up to plus a plus d, then plus a. It means we have just reversed the equation. You notice that our first term here was a, so now and then our last term now is L. Okay, how are we going to reverse? How is this reverse done here? How did I reverse the equation? You notice that this is the last term. So for me to have the other term, I have to take the last term minus the common difference, which is d. And for me to have the other term, I have to take L minus the L minus 2d. It means that if I take L minus, like this is my L, right? For me to have the term before L, I have to take L minus d. Okay, it means if this is 4, it means, or let me say if this is 6, it means this is 4, provided d is 2. Okay, I hope you guys are understanding. So if this is 6, right, and then this is 4, provided that my d is 2, and then it means that if I'm going again, so if my d is 2, it means here I'll have 6 minus 4, here is 2. So you notice that my highest term here is 6, the next one is 4, the next one is 2. So that is why the reverse process is done this way. Okay, so you are taking the last term minus the common difference, the last term minus the common difference. Okay, so and this is the last term minus the common difference for the second term. This is the last term minus the common difference for the third term. This is the last term minus the common difference for the fourth term, right up to where we have a plus d, then plus a. So it means we're actually going back right to the last term. Okay, right to the first term. All right, so I'm moving from the last term right back to the first term. Here we're moving from the first term to the last term. Okay, now what do you notice if we decide to add the two equations? Okay, if you add the two equations, right, we are going to have that our 2Sn, because we have Sn plus Sn is 2Sn. So now I have a plus L, which is a plus L, that is it there, and then I will have A plus D plus L minus D. You notice that D, positive D plus negative D will give us 0. That is why I have A plus L. Okay, again, A plus 2D plus L plus 2D is the same thing. They will fall out. So since there are n terms here, okay, I hope we are understanding. Since there are n terms, okay, so it means that our um as I said, since there are n terms, it means that you cannot actually know the number of terms, because you count the 1, 2, 3, 4, right up to these terms here. So since there are, I can just assume that since there are n terms, okay, but I can derive it. Let me say my number of terms here are 5. So it means since there are 5 of them, so my S5 will be just equals to 5 times all this. But since there are n terms where n I don't actually know n, okay, so that is why I said since there are n terms, then 2Sn is equals to n times A plus L, okay, and from there we can divide all through by 2. Hence, our Sn is just equals to n on 2 times A plus L, where L is the last term. And we have to notice that the L is still the n term. Okay, so where L is the last term, but L is also the n term of an AP. Hence, L equals to A plus um L equals to A plus n minus 1D. How? Because from here, right, Sn is all this right up to Tn, where Tn is the last term also. So that is why I said L is also the n term of an AP. All right. So um, with this now, right, since that we also know that L is also an n term, it means we can substitute this value here where we find L. Hence, Sn is n on 2 times 2A. Okay, because if I put, like, let me explain it well. So let me say this is my L here. This is my L. Now, if I take this L, right, I substitute it here. If I take this L, and then this L I substitute it here, what am I going to have? You notice that I'll have A, I'll have this A, like I'll have A plus, I'm talking where the I highlighted with red, Sn equals to n on 2 plus A plus L. It means that this A will combine with this other A to give me 2A. Okay, and then again, what again? Then I will have now this part here. I have all this part here as this. Okay, so that is it. I hope it is clear. So hence the sum of the first n term of an AP is given by this. So we all know the formula, and we all know this formula. All right, so let me clean our slides. All right, so that is the sum. All right, so let's look at some examples under this, what I just done. Okay, 1, find the sum of the first 6 terms of an AP whose first term is -4 and the last term is 14. So you notice that here they're talking of the last term, so it means we are just going to use this formula up here. Okay, so solution, we have n equals to 6, a equals to -4, and l equals to 14. Hence, from Sn equals to n on 2 times a plus l, we are going to substitute our values. We have 6 on 2 times -4 plus 14, and we know that -4 plus 14 is 10. 6 on 2 is 3. 3 times 10 is 30. Hence, S6 equals to 30. All right. So, this is a mistake I made here. This is actually a mistake. All right. Anyways, I failed to animate this light. Anyways, let me just explain. Because it's not easy. That is, I forgot to animate this slide. Okay, all right, let's look at the arithmetic mean, AN. So if an AP has 3 consecutive terms, P, Q, and R, then Q, or here was supposed to be then Q is called the arithmetic mean of P and Q and R. Okay, so that is if P, Q, and R are in an AP, then the common difference D is obtained as follows. So for us to have the common difference, as we all know in an AP, for us to have the common difference, you can take the second term minus the first term. So if P, Q, and R are in an AP, means you have P plus Q plus R, right? It means I will take, for me to have the common difference, I will take Q minus P. So that's why my common difference here is Q minus P, or you can take R minus Q, or R minus Q can still give you that will still give you the common difference. And I can call this equation 1 and this equation 2. But since both of them gave me the common difference, I can just equate them. Hence, if I equate both equations, I will have Q minus P equal to R minus Q. And notice that I will send this Q this side, I'll have 2Q. Then I'll take this one this side, I'll have R plus P. Hence, my Q is R plus P divided by 2 if I divide all through by 2. So this is known as the arithmetic mean. Okay, so Q now is the arithmetic mean of P and R. Alright, so let's look at an example on this. So this is the example here. Sorry that I failed to animate this slide, but it's not easy. Alright, so given that x minus 10, 5, 6x are three consecutive terms in an AP, find the value of x. Okay, for you to solve questions of this form, right, you are just to use this procedure here to solve them. Okay, so let me say my x minus 10 is my first term, which is P, and then my 5 is my second term, which is Q, and then my 6x is my third term, which is R, right? So it means I'll take my Q minus P, and what is my Q? My Q is the term in the middle, which is 5. That's why I took no, sorry, sorry, I'm just using this formula here directly. Okay, so this is actually ordinary level. There's no need of emphasizing deeper. Alright, so I'll just use this part here. So which of them is my middle term from here? You notice that Q is arithmetic mean, right? So it means I'm going to use 5 here as the arithmetic mean. Okay, so I'll have 5 equal to R plus P. And what is my R? Notice that my R is the last term. That's why I took 6x plus P, which is my first term, which is x minus 10. So 6x plus x minus 10 divided by 2. I'm just using this part here. Okay, and that will implies 5 equals to 7x. 6x plus 6x is 7x minus 10 divided by 2. Then I can cross multiply, so that I will have 5 times 2 equal to 7x minus 10. Okay, hence 5 times 2 is 10, which will be equal to 7x minus 10. Okay, implies that my 7x will just be equal to 20, since this 10 here will cross and meet this other 10 this way. That will give me 20. Hence, my x is just 20 over 7. Alright, hope it is clear. Alright, let's go to the geometric progression. Okay, though you're actually seeing all what is here, but that's a mistake I did. Alright, consider the sequence 12, 3, as I earlier said in the first slide, that a sequence is of this form where the terms are separated with a comma. So consider the sequence 12, 6, 3. Observe that each term of the sequence is gotten by multiplying the previous by 0.5 or by half. So it means that if I multiply 12 by half, I'll have 6, and if I multiply 6 by half, I'll have 3. So that is, I have my first term 12 and my second term, but I got this, the second term is gotten by multiplying half times 12 times the previous term, which is 12. Okay, so this is my first term. For me to have my second term, I'll multiply it by half. For me to have my third term, which is 3, right, I'll multiply the first term with half squared, that is 1/4, and that continues right up to the term that you want to end. Okay, now you have to notice that why did I choose to multiply? For me to have my next term, why did I choose to multiply by half? Because from here, right, if I take 6, the first divided by the second, I'll have my answer as half. And then if I take 3 divided by 6, I'll still have half. Hence, half is a common ratio denoted R. Okay, so that is it. So such a progression where there exists a common ratio is called a geometric progression, whereas for an arithmetic progression there must be a common difference between any two consecutive terms or between consecutive terms. Alright, so let's look at the terms of a GP. The n term of a GP with first term A and common ratio R is given by this: UN equals to A into R, A times R power n minus 1. Okay, n in R, n in n. So n should be a natural number. So hence in a GP, the first term un is like the first term u1 is a, and u2 is a times r, where r is a common ratio. And for us to obtain the u3, we have to take a times the common ratio, and then we square the common ratio. For us to have u4, we have to take a times the first term times the common ratio, and then we cube it. That is from this formula, right? If here is 4, it means I will have my first term times the common ratio, and then times 4 minus 1, which is 3. So that is what this point here is actually talking about. All right. So let's look at an example on that. So example 1. So we have the first term of a GP is 2 and the common ratio is 3. Find the full term. Okay. So let's look at the solution. So from un equals to a times r n minus 1, and my a is equal to 2, while my r, which is the common ratio, is 3, and my find the full term, and my n equals to 4. It means that for the full term, we have u4 equals to a times the common ratio, then I cube it. Okay. All right. Hence, u4 is 2 times 3 cube. So my 3 cube is actually 27, times 2 is actually 54. So that is the answer. All right. So for the second question, we have given that 14, 7, 3.5, right up to some value we don't know, are in a GP. Find the eighth term. All right. Again, given that 14, 7, 3.5 are in a GP, find the eighth term. All right. So what are we going to do for the first term? It means we have to look for the first term. Okay. So for the first term, we already know it, which is 14, and I can call that equation 1. Then, because for us to obtain the eighth term, right, we have to obtain the common ratio, because actually we can actually obtain the common ratio directly from here. We can take 7 divided by 14, so our common ratio can be half. But for a better demonstration, I have for first term a is equal to 14. I can call that equation 1, and for the second term I have a arrow, which will be equal to 7. So for me to obtain the second term, I have to take the first term, then I multiply it with arrow, then I equate it. So that is my second term. Okay. Now you can see that I have a equals to 14 and I have a here, so I can substitute equation 1 into equation 2. Okay. So I will have my here is 14, so I will have 14 r equals to 7, and from there I can get my r, which is half. All right. So now from for fourth term, right? It's a mistake somewhere. It was supposed to be for eighth term, not for fourth term. So this is actually wrong. It was supposed to be for fourth term, for eighth term. For eighth term, where is it? For eighth term, yeah, for eighth term. Okay, which is u8. Okay, which is u8 equal to for fourth term we have a times r root power 8 minus 1, so we have 7. Hence for u8 we have 14 times our common ratio, which is half, and then half times half raised to the power 7. So if I take 7 to the power 1 to the power 7 is, let me take my calculator, 1 to the power 7 is actually 1, and then what about 2 power 7? 2 power 7 is 128. Okay, and then you take 1 divided by 128 times 14. So I have 7 over 64. So that is the answer. Okay, so I think this is the end of the video. Please do the rest case as assignment. Okay, which two cases are left? So the rest case I'm talking of, you have to look for the sum of a GP. Go and read the notes on the sum of a GP, and then if any question maybe you cannot understand it, you can reach me on WhatsApp or in the comment section. So it depends on you. You can reach me of any of the part that you think. So you are left with the sum of a GP, and equally you are also left with the geometric mean. So I think I will upload that geometric mean and the sum of a GPA, because that geometric mean is very important. It's an important something there, but I decided not to make this video to be too lengthy, because if a video is lengthy like that, you actually increase your cost of megabyte in watching one video. Hence I decided to condense it here and end here. Alright, this video was actually dedicated to, before the beginning, the video is actually dedicated to ordinary level students doing mathematics. So it is very important for those doing additional mathematics and those doing mathematics. Note, you'll be using all these parts, all these common ratio things for those of you who will do further mathematics in the advanced level. That you'll be given a sequence, you n in n, that you should do what and do so that they can ask you that is the sequence increasing or decreasing, and you should look for the first that term. So it is very important. This video is very important. Okay guys, this is the end of the video. Don't forget to subscribe if you find the video helpful to you. All right, see you guys in the next video.